So after doing a couple of lessons of recapping stuff from grade 9 in geometry, or what we call from now on Euclidean geometry, we are finally learning something new today, and we're starting with parallelograms. Okay, parallelogram looks like that. Okay, we've got two pairs of sides that are equal and parallel to each other, and we're learning a bunch of theorems. Actually, half of these theorems already spoke about, you know it. Okay? So, if you've got a parallelogram, then what you know is that opposite sides are equal. We know that, but now we call it a theorem. Okay? If you look at page 169, I think it's theorem 1. Okay? So, giving some letters, just want to see. So, A, B, C, D. So, if they tell you this is a parallelogram, then you can say AB equals CD. Why? What's the reason? You always have to quote the reason. Equal side, equal opposite side in a parallelogram. Okay? A parallelogram, by the way, you usually write like this as a shortcut. Okay? So that's theorem 1. The second theorem is that, again, if they tell you you've got a parallelogram, then you know it's not just the sides, the opposite side that equal, it's also the opposite angles. So, angle C will be equal to angle B, and angle A will be equal to angle B. Okay? So far, not much new. Okay? But I'm giving you like the reason, the code for the reason. Because every time you have to quote the reason. Another one that we actually spoke about last lesson, okay, in our revision. Okay? If you've got a parallelogram, you also know that the diagonals bisect. What does that mean, the diagonals bisect? These are the diagonals. What does it tell you? They meet in the middle. Okay, so if this is E, for example, then can you give me an equation? You quote an equation? AE equal to ED. And BE equal to EC. Okay, that means diagonals bisect. They halve each other. Okay? Do they bisect the angles as well?
Yeah. No.
That was in a rhombus and a square. Okay, not in a parallel. You can see they're not the same. Okay, so these were the three theorems. Okay, if you got a parallelogram, you know three things: opposite side will be equal, opposite angles will be equal, and the diagonals bisect. Now comes the difference or the addition. Each one of these theorems has what we call a converse. You ever heard of a converse?
Yeah, it's a shoe.
It's a shoe, right? Yeah, it's a shoe. Okay? But when it comes to maths, it means the opposite. Like the reverse. So, if you have a parallelogram, that means the opposite side are equal. But it means that if you have a quadrilateral, that means a shape with four sides, and opposite sides are equal, then you know what kind of shape you have? A parallelogram. So it's the converse. Each one of these theorems have a converse. Or another example, if you have a quadrilateral, okay, and opposite angles are equal, what can you say? What shape is it? Parallelogram. Yeah? And if you have a quadrilateral that with the diagonals that bisect each other, you have a parallelogram. Okay? Alright? So there's really three theorems and their converse. And I specifically wrote them in different colors so you understand. Okay? Alright, so if you have, let's say, you can prove that you have a shape with two diagonals that bisect each other, then you can say that's a parallelogram. Why? Because the diagonals bisect. That's the reason. There's one last thing that we really didn't discuss. I'm just going to pause it for a second. That must have hurt. Oh, and he's still, yeah, okay, so pause. Hang on. Pause. Alright, so one more way of proving that a shape is a parallelogram, and that's this business. So if you have a quadrilateral, where you don't know about both pairs, but you know that you have two, let's just draw a picture. Okay, so let's say you have a quadrilateral, and you know, let's say, that AB is equal to CD. The two opposite sides are equal. You don't know anything about AC and B. You just know that this is equal to that, and you know that it is parallel to each other. You've got no idea about these two sides, but you know that this side is equal to that side and it's parallel to each other. You've got one pair of opposite sides which are parallel and equal. Then you can say confidently that the shape is a parallelogram. Okay?
Wait, so what if they have opposite sides parallel and
equal sides.
Okay? You see the difference here, you have to show that both sides are equal or both sides are equal. So that is equal to that and that is equal to that. You have to show it on both sides, both pairs. Here you have to show that this angle is equal to that angle and that angle is equal to that angle. It's not enough to show just about one pair, you have to show both pairs. The difference is that in this theorem, you're only required to show that both these sides are equal and parallel. You don't need to show anything about that. Does that make sense? Okay? Just to recap everything, okay? These three theorems, you have to prove them on both pairs of sides. This one, you just need to show on one pair. But you need to show that they're both equal and parallel. I'm going to stop here. We're going to try and practice some questions and maybe I'll add to that video. Okay, so I'm just going to solve one question. It's not too difficult, but I think the main thing here, guys, is to be meticulous in the reasoning, to write down all the reason properly. Like I told you before, it's kind of like being a lawyer. Okay? You're solving problems in geometry, you have to be a lawyer. You cannot put a statement without backing it by a reason. So it's exercise 2A. So I'm given that this is 2x minus 30, this is 2x plus 10, and I know this is a parallelogram. So what I would say, okay, look, if this is angle A is equal to angle C, that means they're both 2x minus 30. Why? Opposite angle equal in a parallelogram. You have to mention it's a parallelogram. The same thing for B and D. They are equal, so B is also 2x plus 10. Reason, the same reason. Okay. Then I'm adding all the angles up. So 2x minus 30 times 2, because there's 2 of them. 2x plus 10 times 2, because there's 2 of them. All together, they add up to 360. Why? Sum of angles in a quadrilateral. Okay, just like in a triangle, we have sum is 180. Quadrilateral, it's 360. A bit of algebra, adding. And I got x is equal 50. Hope I got that right. Okay, I'll just pause that and see if there's anything else I need to add. Okay, as I was told here, okay, there are different ways of doing it. One possible different way you could do is say, look, these two lines are parallel, because obviously it's a parallelogram, and these two angles are cointerior. And if you remember, if they're cointerior, that means they add up to 180. That's actually, I would do it like that. I just want to show the theorems that we just used to show how we use them. But that is more clever. You add, you say 2x minus 30 plus 2x plus 10 must be equal to 180. Why? Cointerior angle. And then you can find it. Okay, I'll stop here. Thank you very much.